if I can have everybody's attention. Spencer, if you can kill the lights, please. All right, nobody should be working on homework now. Everybody should be focused in on paying attention to this particular quiz. And if I was to give a motif, if you will, a theme to today's quiz, it is reverse inside the parentheses. Now, first question says, Keith determines the zeros or the roots of a function to be -6 and 5. What could be Keith's function? Remember, if the answers work out to be -6 and 5, then the packages from which you split them apart and say maybe it's the guy on the left, maybe it's the guy on the right, needed to be the reverse of that. So if this is 5, the package needed to be x minus 5, so that when you write x minus 5 equals 0 and then add 5 to both sides, you get the positive 5. Likewise over here, x plus 6 is 0, you subtract the 6 and you get -6. So the correct answer is choice 3. Again, the theme of this quiz is to remember when things are inside grouping symbols, parentheses, you look to reverse. Now let's go to number 2. And I can recall, I believe, that this was on the first ever Regents exam for Common Core. And I remember reading the question and going, what the heck? And my instinct was to start to do this. It says here g of x is f of x minus 2. So I put in an x minus 2 in every one of those places. And I did x minus 2 squared, minus 4 times x minus 2. And then I started doing a whole bunch of algebra and came out with this. And it was a 2-point question. And I said, that is way too much work for these kids to do 2 points. And then I went, oh, Mr. Lindquist, I actually call myself Bob. You're an idiot. It's in the package. What kind of shift is in the package? Horizontal. Spencer, you got 100 and you said vertical. Did I? Yes. Now, it's horizontal shift. And horizontal shift, any zeros, roots, anything in a package is reversed. So this means I have to move 2 units to the right. Every single point goes 2 units to the right, like on the last 2 do-its. Remember how I took on the last 2 do-its and we moved it either vertically if it was outside the parentheses or horizontally if it was inside? So if it was 2, -1, and I moved 2 units to the right, it's now 4, -1. Done. So all you needed to do was realize, when you see it in the parentheses, you move, in this case it's -2, 2 units to the right. What if it would have said +2? To the left, 2 units. What if the -2 was outside the parentheses? -2 outside the parentheses. Everybody? Down 2. What if it said +2 outside the parentheses? Up 2. So this is really a quick and easy quiz. And the purpose of it is to emphasize to you that when in parentheses, we reverse things. All right? Are we good? All right. Now I would like to go to yesterday's homework. Here, by the way, here's yesterday's quiz. Do it, remember? We took and we moved down 1, and I made another mistake yesterday that we didn't go over in here. We went over in the other class. I didn't realize that each box was only a half. So when we did the first one yesterday, we should have went down 1, which was down 2 boxes. I should have done that. Okay? So we did something just like that yesterday. What I really want to get to out of yesterday's work, though, is the homework. And I want to go over the first 2 questions and the 4th question. All right? So let's do that now. I know usually I project the answers, but today I want to actually do them because I want to show you why it is that we're learning about this horizontal shift, vertical shift, this coefficient in front. Now, this is all about making things sketches, quick and easy. It's not supposed to be super exact, okay? So what I'm going to do first is draw my axes. Here they are. X, Y, and I am sketching. Sketching is a very important word. I'm doing the sketching because I don't want to take the time to be super exact. If I want to be super exact, I'm going to put it in the calculator. I'm going to generate a table, I'm going to write the table down, and I'm going to plot the points. But f of x is equal to x cubed looks like that. Okay? Now, if I want to do 2x cubed, what is the effect of this 2? Makes it taller faster. Very good. So everything moves up twice as high. So my graph would be a little on the inside of it like that. Good. What is the effect of the 0.5? Right here. What does that do to the graph?
Makes it 0.5 times 1.
Yeah, it's going to make it not grow as fast. It's going to grow slower. So there it is. Again, it's quick sketches. You don't have to be exact here. What would be the effect of the -3?
It's going to go in the opposite side of the graph.
Yeah, it's going to flip, okay? And it's also going to get even more narrow. So if I flip and get more narrow, what would have gone up here is now negative, and it's going to get more narrow. So it'll go like that. Okay? All right. Any questions? All right. So now, let's take the same idea. And remember, we also talked yesterday about the importance of sight recognition, how my niece is learning these words at River Avenue that are just sight recognized words. You don't sound them out. You just see it and know it. Like you don't go, you just go, bah. You see it, you know it. Y equals x cubed. You know that that graph looks as we just drew it. The next graph that we talk about in here is the absolute value graph. So you just need to be able to recognize or know, oh, that's awful. You need to recognize or know the absolute value graph. So first is y equals absolute x, and that looks like that. Again, graph recognition. You just know absolute value comes to a v. Next one is 4 times the absolute value. So as Spencer said before, this coefficient of 4 in the front, what it's going to do is take whatever this graph is and make everything 4 times higher, each and every point. So this guy here goes up to 4. This guy here would go up to 8, which I guess is around there. So that would be a quick sketch of absolute 4x. Now, absolute 2x is going to be in between the first two graphs, okay? Because 2 is twice as high. Now, you might have thought to yourself, the 2 could be on the outside, but in the case of absolute value, it doesn't make any difference. So there to there. And then the -2 is going to do what to the graph? Flip the green one. So it's not as wide as the red one, not as narrow as the blue one. It's the flip of the green. Okay? Any questions? All right. So those are all about quick sketches, just understanding the behavior of graphs. Now we get to number 4 here, and this is another chance to do it, except this is 3 to the right, down 2. So the y equals x squared graph, remember we said yesterday we noticed the pattern with 1, 1, 1, then 3, then 5, 3. Here's my basic graph. And now I want to move every point, what did it say, 3 units right, down 2? Okay, so I just take this point, 3 to the right, 1, 2, 3, down 2. 3 to the right, down 2. 3 to the right, down 2. 3 to the right, 3 to the right, down 2. 3 to the right, down 2. And there's my graph. Okay? So again, this is all about behavior and quick sketching. Behavior and quick sketching. We're not looking for works of art. We don't need Picasso, we don't need Rembrandt, we don't need Van Gogh. We need kindergarten. Okay? Any other questions? All right, so now let's work on today's sheet. Yes, buddy.
So I forgot to check how much I was taking the quiz.
What was that?
So I forgot to check on how much I was taking the quiz.
Oh, just show it tomorrow. You get full credit. All right? Now, here's the deal. If you remember a while back, in fact, let's go to things a while back. Somewhere, just squeeze this in on your paper. Solve using the quadratic formula. Bless you. Yeah. Solve using the quadratic formula. I hope you remember the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Take a moment and just cut your way through that one. God bless. God bless you. Bless you. Okay. I hope everybody was able to get the answer I just did in green. Okay, we comfortable with that? Okay. We worked on that, whatever, 2 weeks ago, 3 weeks ago, I don't even remember when it was. And the big thing to realize was, whenever we solve a quadratic equation, the first option we always want to do is factor. But if factoring is impossible, we've got two second options, completing the square and the quadratic formula. And some kids really like the quadratic formula. I was actually tutoring an 11th grader in the high school, or a 10th grader in the high school. And I looked at her work when it said to solve quadratic equations. She had to do 4 of them, and she did every one of them with the quadratic formula, even though every one of them was factorable. And she just said, I like the quadratic formula. I know what to do. It always gives me the right answer. And she is right, it does. Now you really do need to know how to factor. But the quadratic formula always works, hence the name, quadratic formula. Formulas always work. But we really didn't talk much about what it means. We talked about how to do it, how to get to the answer. When we talk about what it means, there's 2 different ways to interpret this. One way to interpret this is to express the decimal, the radical as a decimal. Can everybody get your calculator out and type in square root of 24? It's going to be like 4.9-ish. And give me the square root of 24 to the first 4 decimals. 4.8987?
Yeah.
Good. Over 2. And then if I want to go a little bit further, I have 2 possible answers here. I have negative 2 plus this, which is going to be 2.8987. And I got negative 2 minus this, which is negative 6.8987. And then in both cases, I need to divide by 2. And then whatever that works out to be, I don't even care. The bottom line is, it's possible to express it as a decimal and give you a decimal answer. And sometimes they will say to you, find to the nearest tenth, or find to the nearest hundredth how long it takes the ball to reach its maximum height. And you just plug it in and you work it out and you get it all done. How long does it take for the ball to, that actually wouldn't work for the nearest height. That would be, I would want the axis of symmetry. How long does it take for the ball to get back to the ground? That would work for that kind of question. Converting to a decimal, not a problem. Using the formula, not a problem. When we did it, way back when, I said to you, we're going to have to come back to this. And now is when we're coming back to it. I said that it's possible sometimes to simplify the radical. Now, if you were taking a math test, and on that math test, it worked out that the answer was 4/8, would you leave your answer 4/8? No. What should you really do with 4/8? Simplify it. You should make it all the way down to a half. Even if you try to simplify it, Spencer, and you get down to 2/4, you're still not there. You gotta go to a half. So we're about to do simplifying radicals. Now let me tell you a little something about simplifying radicals. When I first came to this school district, it was just before Hurricane Gloria in October of 1985. I came here in September. I was supposed to student teach, I never did. I sat in on a couple of classes though, and a very great teacher by the name of Mrs. Runkle was up there. She was teaching 11th grade students. And she said to the 11th grade students, we're about to do simplifying radicals. This is one of the hardest topics for students to do. They get very frustrated by it very quickly. And I watched as 11th grade students really had a difficult time simplifying radicals. So my experience is that this is going to be an annoying topic for you. It's an annoying topic for a lot of 11th graders. To be able to do well with this, you gotta have pretty good times tables, and you really do need to know your perfect squares. So I'm going to do this one quickly to give you an idea of how to do it. Then we'll go back to the lesson sheet and we'll work it through on there, showing you a little bit more work. What it says right here is -2 plus or minus the square root of 24 over 2. Now, I can simplify the square root of 24 because the square root of 4, which is 2, divides into it. So I'm going to trade in the square root of 24 into square root of 4 times square root of 6. I think you can see going backwards that 4 times 6 is 24. And then I'm going to make the square root of 4 2. So the answer becomes x is -2 plus or minus 2 radical 6 over 2. And then I go die or cancel out all the 2's, and I get -1 plus or minus radical 6. Now, we're not going to do the quadratic formula today, but we are going to work on the part of the formula that gets the radical 6, and then we'll build up to the formula. We may do one example of the formula today, but tomorrow we'll do a lot of examples. All right, so let's get back to today's lesson sheet. Simplify each of the following radicals. Here's the process for simplifying radicals. You know how when you simplify a fraction, you choose the greatest common factor? The biggest number that divides into both? Now what you're going to do is find the biggest perfect square that divides into both. Yesterday in class, I started listing the perfect squares. 0, 1, 4, 9, 16, what's next? No. 1 squared, 2 squared, 3 squared, 4 squared, 25,
36, 49, 64, 81, 100, 121, 124.
All right, usually you don't need to get any bigger than that. Now, what your job is, and I counsel kids, because this can be an annoying topic for kids for whatever reason. I counsel them, and some of you will get it easily, some of you will find it annoying. I counsel kids to, on their paper, when you take the test in this unit, and when you take your Regents exam, just write that list right across the top of the page. Now, the next thing you're going to do is ask yourself, what's the biggest perfect square on that list? That's the list of perfect squares. That divides evenly into 8. What's the biggest number on this list? And you should read the list this way to find the biggest one. What's the biggest one that divides into 8? 4, right? So I'm going to change radical 8 into square root of 4. Now 4 times what will get me 8? 2. So the square root of 8 becomes square root of 4, square root of 2. And what is the square root of 4? 2. So the simplified version is 2 radical 2. Okay? So your job is to find the biggest perfect square that divides into whatever number they put under the radical, divide it in, and then see what's left over and simplify. Get it? All right, let's go to the square root of 98. You do it. is the biggest perfect square that divides into 98? Anthony?
81.
No, it's got to divide in evenly. It can be no leftover. Kim?
49.
49. So I'm going to go square root of 49, square root of 2. Anthony, thank you for bringing that up because I wasn't clear about that. And now everybody, I think because of your question, everybody understands that. All right, and what is the square root of 49, everybody? 7. So I get 7 radical 2. Okay? All right, you do the next one, square root of 500. Look for the biggest perfect square on the list that divides into 500. Yes? Divides into evenly. For instance, for number 20, 1 divides into it, 2 divides into it, 2 does not. 2 goes in 10 times, 3 you can't multiply out to be 20. 4 does, 5 does, 6 does, and 7 does. Numbers that divide in evenly with no limit. You'll notice that you really can't do your calculator really doesn't do this, okay? All right, so what's the biggest perfect square that divides into 500? Anthony?
250.
250 is not a perfect square. If you tried your calculator and typed in square root 250, it wouldn't work. Yes?
100.
100, good. So this would be square root of 100 times the square root of 5. What is the square root of 100? 10. So I get 10 radical 5. Next one, cube root 16. What do you notice is different? Cube root. So now, I don't want the list of perfect squares. What list do you think I want?
Perfect cube.
The list of perfect cubes. Well, let's make that. Ready? What's 1 cube? 1. 2 cubed.
8,
3 cubed.
27.
All right, now it's pretty obvious to me that we've already gotten too big. At first, cubes look like they're going to be really hard, but you can't really do too many of them because they get so big so fast that it's not that hard to do. What's the biggest perfect cube that divides into 16?
8.
8, good. So this is going to be the cube root of 8 times the cube root of 2. What is the cube root of 8, everybody? 2. So I get 2 cube root of 2. Any questions? All right, so this is the new skill that you needed to learn for today. Tomorrow, we'll start doing questions like this with the quadratic formula, where we use the quadratic formula, but at the end, we add in our last simplifying step. And Janelle, Haley, and AJ, I keep finding calculators on your row at the end of class. Right? Hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot, ciao, arrivederci, adios amigos y amigas, cheerio, garushurus, office, shalom, sayonara.
Did you collect the tape?
Oh, double period.
I did.